All right, the notes we're going to do right now are the notes that we did on Wednesday, October the 22nd, I believe. And the homework before this was how to separate substances, and you took a little quiz for homework questions. So if you were absent, yes, on Tuesday, be sure that you've got that homework done. So chromatography is a way you can separate components by passing the mixture through a filter, where each component is going to move at a different speed. The reason they're going to move at different speeds is because they have different weights. So if you take like a black ink and color this part of the paper down here and put it in a solvent, the ink molecules are going to start to travel up the paper. As they go up, heavy ones are going to move more slowly. Medium weight ones will move next. And these would be the lightest. So the speed of the molecules, because of the size, is going to be different for each one, and those dye molecules will actually spread out. Distillation separates liquids with distinct or different boiling points. Normally during a year I do a distillation, but everything's packed away. So in a distillation, this would be a mixture. And the mixture I usually use is alcohol and water. These have two very different boiling points. So when you start to warm this up, you're going to start to see bubbles, and it looks like the whole thing is boiling. Really, the only part that's boiling is the alcohol. The alcohol will then boil and turn into a gas, and of course, as it rises, it's going to cool. When it cools, it'll eventually condense back down through here and then drip into your beaker. So what you're catching here in the beaker would be 100% alcohol. Once the distillation is done, you've removed all the alcohol, and all you're going to be left with is water. Other methods of separating things are centrifugation, where you're going to be using different densities to separate things. Evaporation, where you just allow the water to come out and you're going to be left with the solid. Filtration, like using a colander to filter your spaghetti from the water. Magnets will work if you have a metal mixed with something else that's not metallic. Decanting separates immiscible. Immiscible means not dissolvable. Whoop. Separates immiscible liquids or insoluble solids from a liquid. Basically what you're doing in this is you've got your solid and you're just pouring off the liquid part. The last one is recrystallization. This is where you've got two different compounds. One is more soluble, the other one is less soluble. And you can cause it, the more soluble one will remain dissolved. The less soluble one will crystallize out. So you'll end up with these crystals down here in the bottom. So this is basically a summary of everything we did in these notes. The first, we've talked about states of matter. We said that a solid has a very definite pattern or definite structure. A liquid has a less definite structure, and a gas has no structure whatsoever. Solids have definite volume, liquids have definite volume, and gases have an indefinite volume. And you can see the shapes for yourself. Intermolecular forces in a solid are going to be high. In a gas, there are going to be no intermolecular forces. There's no attraction between those particles. As far as energy go, gases are going to have a high energy. They are moving quickly. Solids are going to have low energy. They're just vibrating in place. Liquids are going to be somewhere in between. They're going to have medium intermolecular forces and a medium amount of energy. We also talked about phase changes. If you go straight from a solid to a gas, that's going to be sublimation. If you're going straight from a gas to a solid, that's deposition. And then you're already familiar with melting, boiling, freezing, and condensation when you're turning a gas back into a liquid. The other topic we talked about is the composition of matter. We said that it can be broken down into pure substances, which means that it's 100% all the same, or a mixture, which means they're mixed. For a pure substance, what you have to look at is, do we have a compound, which means we have two or more elements combined, and these would be different elements, or do we have an element itself, which means we've got the same type of atom. It doesn't matter if I've got two together. If those two together are the same kind of atom, that's still going to be an element. Now, then we also talked about mixtures. And we said, is the composition uniform? And we used the word blended. If it's blended, it's a homogeneous mixture. You can see that this looks like it's very well blended. If it's not well blended, that's a heterogeneous mixture. We've got areas where we've got big globs of things. Heterogeneous mixtures, we can further separate those down by saying, will it settle out? Will those parts, if it's in a fluid, settle out? That's going to be a colloid. If they will settle out, that's going to be a suspension. We're going to talk more about that in the other notes. We also talked about properties of matter. We have chemical properties. This is how things will react with other elements. Or physical properties. These are things like conductivity, color, odor, and other properties like that. Physical properties can be further separated into intensive and extensive. So does the property depend on the amount of matter? If it's yes, then it's going to be extensive. Extensive are things like volume or mass, or as it says, length. If it doesn't depend on the amount of stuff, that's going to be an intensive property. Intensive properties tend to be physical properties, as well as chemical properties. And that was the end of this bunch of notes.